A few questions from Assess, chapter 15, page 236-237. I want to do the scale question. That's only one that's worth doing really, because it's nasty little numbers. So we'll do it. So this is question 4. It says a map uses a scale of 1 to 25,000. Calculate the length on the map that represents a distance of 10 kilometers. In other words, let's just convert that into meters straight away, so we can begin to reduce the numbers down to more visible, sensible units. And 24.8 kilometers, 24,800 meters. Is that right? I just multiply by 1,000 each time. So these are the real lengths. I want to then shrink them down by 25,000 times to see what length they would appear on the map. So here I go. I'll take this is part A. I'm going to take my 10,000 meters, divide by 25,000, and I'll get an answer in meters, which will be most inappropriate for a map, but we'll convert it in a minute. So 10,000 divided by 25,000, that gives me 0.4 meters. That's okay, but if we multiply by 100 now, we've got 40 centimeters. Again, for a map that you open out like that, it's okay, rather than a map on A4 that just would not fit at all. So 0.4 meters, real life, 40 centimeters better. We'll do the same with this one here. We're going to take our 24,800 meters and divide by 25,000. Well, that's the scale. We'll just reduce it down. So 24800 divided by 25,123. Bam. I've got here 0.992 meters. So on this map, if I open it all out, I'm going to have a scale of 99.2 centimeters. Actually, I don't know which is better. Both mathematically correct. 40 centimeters for A, 99.2 centimeters for B. Now, if you open up a great big map, it could well be a meter square. So that's okay. All right, that's that. Question 5 needs some consideration. There it is. Now, it's going to take some discussion. This is really hard to demonstrate on a screen with a graphics pad and without a compass to help me swing round. Anyway, a maths class is asked to draw this triangle accurately. That's the one. Explain why they may not all agree the answer. Well, listen. Let me give you a simulation of me trying to draw this thing. So here I have a 6 centimeter line. All right, there it is. That's pretending to be 6 centimeters. So let me label it. Obviously a lot bigger than that. And this is me pretending to draw a 30-degree angle. So that's about 30 degrees. Pretend. And I don't know, that's not a bad estimate. But that's 30 degrees, say. So far so good, okay? Remember, 6 centimeters with a ruler, 30 degrees with a protractor, and we're ready to go. Now, what of this 4 centimeter line here? Well, the way I would have to do that is to put my compass point right there, open it out to 4 centimeters, and whoosh round. Alright, so this is me stabbing it right there. In fact, let me just extend this line, just to make my point. That's meant to be part of this straight part. Anyway, so put my compass point there, open it out to 4 centimeters, and whoosh round. This is what's going to happen. So here's my 4 centimeter arc coming through. Bang, there it is. So, do you see, some students may draw the line from here to here and get this answer. Other students may draw the line from this point to here. They will both have a radius of 4 centimeters. In other words, they're both correct. So some students would do this and go for that one. Other students will go for this and do that one. And they're both correct. Alright, so that's a 4 centimeter line. It looks different to that one, so probably this is the one that's representing the book. But it's not drawn to scale anyway, so unless you do it for real on page, you can't really tell. So these are the 2 possible answers. Up there, down here, and across, one answer, or up here, down the shorter length here, then still going down the 4 centimeter line and back across there. Do you see? There's 2 possible triangles. Explain why they may not agree on the answer. there are two possible triangles. And the way to prove it is to actually draw this out the way I've tried to do it, but you can do it really accurately with a protractor for there, a ruler for there, and of course you get the arc sorted with your pair of compasses. You just measure radius of 4, opening out, whoosh round, and there's two possible answers. That's the reason for that. And I fancy doing question 7. There it is. It says draw this rectangle accurately. No, I'm not going to do that because it's there for us. I'm not going to just draw a 5x4 here. It's just a waste of time. What I want to focus on is this: bisect the angle ABC. What does that mean? It means angle B. ABC. This angle wants to be cut in half. Now, don't be fooled. It's not a square, it's a rectangle. So you don't put your ruler from there to there and just draw it, because that will not produce the correct angle. We need to bisect this angle. So remember, you take your compass point and you put it right there, and you just do a small arc straight across. You bring it all the way around like that, so it's an arc, and it cuts the line AB there and the line BC right there. So all these are radii, small ones, maybe about 1.5, 2 centimeters. It doesn't matter, as long as we establish that that length is the same as that length, because we've cut through with our pair of compasses in 2 places with the same radius. Therefore, that section of the line and that section of the line is exactly the same. So we have 2 stabbing points there. One point there and 1 point there. So you open up the compass a bit more, so it comes into this rectangle more significantly. So put your compass point there and swing round like so. Then put your compass point there and swing round like so. And look, we have the arcs overlap as follows. And just like before, you go from where the angle starts. You aim through to where the arcs overlap. And there it is, you bisected the angle. Now, this is extremely inaccurate. I'm doing it by hand, I'm doing it by eye, on the screen, on a graphics pad, and so, forgive me for not being brilliant with this, but it's okay. Remember the principle? Establish 2 equal lines, find 2 compass points, use these as a means of drawing the 2 arcs, as follows, and where the 2 arcs overlap, extend your line from where the angle begins right through to where they intersect, and you've bisected that angle there. It will be 45 degrees, obviously. Mine looks completely wrong, but I'm sure you understand from previous videos and from this one the skills I'm trying to teach. Alright, so when you do this on paper in class, it will be absolutely perfect, and you'll be able to prove that it's 45 degrees by measuring, if you really want to do that. And you won't go anywhere near point D, because this is not a square, it's a rectangle. It's likely to have come more down here, but we'll see when we do it live in class. Alright, so that's the end of section 15. The assess is done. It's now time to revise.